Hey there, everybody. So in today's lesson, I'm going to go over with you how to complete a paired t-test. So this is very similar to the regular t-test for means, but we're actually going to be looking at paired data. Now, it's also known as a matched pairs t-test. So in this example, we're looking at researchers, and they designed an experiment to study the effects of caffeine withdrawal. So they recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. And then each subject was barred from coffee, colas, or any other substance that might have caffeine in it for the duration of the experiment. Now, during the 2-day period, subjects took capsules containing their normal caffeine intake, and then during another 2-day period, they took placebo capsules. Now, this is the important part. The order in which the subjects took the caffeine and the placebo was randomized. And at the end of each 2-day period, a test for depression was given to all 11 subjects. So researchers wanted to know if being deprived of this caffeine would lead to an increase in depression. So we go ahead and we get the results, and we have 11 subjects here. And then if you look on the columns right here, this was their score here for when they had the caffeine, and then this was here when they just had the placebo. So the scores for when they had the caffeine pill, and their scores for when they were just given the placebo. And then what we're going to do is we're going to look at the differences between the two. Now, you can really calculate the difference either way as long as you're consistent. In this case, we decided to do the placebo minus the caffeine because we're thinking that without the caffeine, they're going to feel more depressed, and higher scores are going to show more symptoms of depression. So as you can see on the right here, we're getting a lot more positive values, which seems to indicate that without caffeine, that would basically increase your depression. Now, even though the data seems to suggest that, we want to do a statistical test and see if this really is the case. So, one thing we want to be discussing here is why did we randomly assign the order? Well, basically, we wanted to take out any extraneous variables that might be influencing the results. For example, on one day, the weather might be really, really gloomy. So that could actually affect their depression. On another day, it might be really, really sunny. So if we basically randomly assign the days that they get the treatments, then that will hopefully minimize any extraneous variables. All right, so let's go ahead and carry out the test. So remember, whenever you're carrying out a test, there are 4 steps. You want to state the problem, you want to plan, you want to carry out the statistical analysis, and then you want to make a conclusion. So in this case, we're trying to state what we want to do here. So we have our 2 hypotheses, and we're going to call the mean of the differences that we're going to define that to be the true mean difference, which is the placebo minus the caffeine. Okay. And because no significance level is given, we're going to use an alpha level of 0.05. That's a significance level of 0.05. That means that the probability that we've actually made a mistake in our conclusion at the end is 5%. So if we look at the conditions, we want to make that check first. Remember, we're always checking for the 3 conditions. So the first one is the random one. So in this case, researchers randomly assign the treatments. So that takes care of the random issue. Now here's an important fact. Because we're looking at a matched pairs, when we look at the 10% condition, we're not sampling. So therefore, it's not necessary to check that condition. However, what is necessary, because we're dealing with a sample size of 11, is that we check to see if the plot of the data is roughly normal, or better still, shows no major skewness and shows no major outliers. So if you look at the dot plots, in this case, if you look at the histogram, if you look at box plot, and if you look at the normal plot there, you'll see that we have no major skewness and no major outliers. All right, so let's go ahead and carry out this test. So I'm writing out the example as I go right here. So let's just very, very quickly recap what we have. So when you're doing a test, you always want to state your hypotheses. So we believe that the mean difference between the two groups is going to be positive. We mean that we think that we will see a heightened increase in depression scores. Now, if I'd have switched these two, I would have had to have changed that direction to less than, because I would have expected more negative values. Now, we're going to use a paired t-test, which again is like a regular t-test, and we're going to stipulate that the alpha level is 0.05. That means we have a significance level of 5%. We already checked our conditions, so we're all ready to go. All right, so there's two ways of doing the test. The first way is by using the formula. So really, it's just the sample data or the sample statistic minus the population statistic. So in here, it's going to be the sample difference minus the population mean of the differences, all divided by the standard deviation of the differences over the square root of the sample size. So we need to get all this information. So let's go to our calculator here. So in my stat tables, in L1, I've put all the differences. So we're going to go ahead and calculate that mean difference, or that sample mean difference, and that sample standard deviation of the differences. So I'm going to go to Stats, I'm going to go to Calc, and I'm going to hit one var stats, and then I'm going to go to Calculate. So we can see that the mean difference there is 7.36. So let's go ahead and write that down, 7.36. Now, the mean difference, we would expect there to be no difference if they're, as the opposite. So therefore, we're putting a 0 for that. Now, the standard deviation of the differences is this one right here, so 6.92 if I went to 2 decimal places. And then we're going to divide that by the square root of the sample size, which is 11. So let's see what we get for that. So 6.92 divided by the square root of 11 gives us that. 7.36 divided by the previous answer gives us the 3.527, so about 3.53. So that means my critical value is 3.53. Now, if I had a critical value of 0, that would mean there would be no difference at all between before and after. So because we have a value of 3.53, that does seem to suggest some difference. The question is, how significant is that difference? And is the difference significant enough to say that that caffeine really, or lack of caffeine, really does increase depression? So here's what we're going to do. We're going to create our normal curve right here. Now remember, we're doing a right-tailed test. Okay, so there's 0 in the middle. Remember, these are standardized scores now. So if there is no difference, that's 0. Now we're doing a one-sided test to the right. And because we have a 5% level of significance, that area right there is 5%. So if I get a t-value that's in this region here, that means there is no significant difference. But if I get it in the shaded region, that means there is a significant difference. So to get the actual value that we need to compare it to, or rather to get that critical value, we go to our t-tables. So remember, the degrees of freedom are on the left here. So we have a sample size of 11, which means that our degree of freedom is going to be 10. Because we're also looking at a 5% level of significance, we go across here to 5%. So 10 degrees of freedom and 0.05, that gives me a value of 1.812. So that means the cutoff value is 1.812. Now let's have a look at that. Our score of 3.53 lies way past that in that region right there. So therefore, there is significant evidence to suggest that the lack of caffeine does seem to lead to depression. All right, let's look at it using the calculator. So if I'm going to use the calculator, all right, I could go to Stats, and then I go across to Tests. Now remember, this is the t-test. So if I was doing the calculator version, I would want to say that we're using a t-test. So we are using a one sample t-test here, or in other words, it's of that paired data. All right, so we're going to go ahead and do that. So we're going to go down to number 2. Now you've got 2 options here, data and the actual stats themselves. Because we put in all the data, I'm going to go ahead and hit that data value. Now, the mean difference that we're testing it against is 0. All our data is stored in L1, and we're going to include each value just one time. And we're trying to see that the mean difference is actually greater than 0. So therefore, I'm going to select that one right there. And then I'm going to go ahead and calculate. So as you can see, it gives me my critical value of 3.53, which I got from which I had before. But this is the important one that we need to be looking at, this p-value. So the p-value is 0.0027. So I'm going to go ahead and write that down. Now again, don't get that p-value confused with proportions. In this case, and if you want to, you can just write down p-value. Might actually be the better thing to do. I get a value of 0.0027. That means the probability that my results were due to chance is 0.0027. That's about 0.27%. So really, we wouldn't expect these results to happen if it was purely just a chance alone. So let's write out our conclusion. All right, so here we go. Because our p-value is lower than our significance level of 5%, that means we are going to reject the null hypothesis. So if I go back up here, that means we're saying that, no, we're not saying that this is not true. We're just saying that there's not enough evidence to suggest that it's not true, okay? Because I could do another experiment and get slightly different results. This just means there's a 5% chance that my results are going to be incorrect. Actually, because the p-value is 0.0027, that means there's a 0.27% chance that I would have made an error in my conclusion. So because our p-value is lower than 5%, we reject the null. So this is the important part. There is sufficient evidence to suggest that a lack of caffeine can cause depression. Okay, so that's my conclusion. So when you're doing these kind of questions, it's very important that you have these 4 steps, that you state what it is you're trying to figure out. You make a plan, test those conditions, do the significance test, and then finally come up with that conclusion. Now, one last thing about the conclusion. When we're talking about inference, think about how you obtain the data. We didn't pick the data randomly from the entire population, so therefore we can't make an inference about the population. However, because we did an experiment here where we randomly assigned the groupings, we can make an inference on cause and effect. So therefore, it does seem to suggest that there is that lack of caffeine can cause that depression. Okay, thanks very much. If you have any questions, please let me know.